Okay, here we go. We are Section 2, Design and Specifying Information Systems, and this is the second part, so I call it Section 2.2. We already talked about data models. We talked about the types, conceptual view. Then you have a logical view, looking at it. And in a lot of data models, they have a physical view. So it kind of goes like this. You get this big picture of what you want to see, and then you can logically design what you want it to look like. And then that logical can move into more physical, more or less you start actually creating tables in MySQL. The schema is more what it looks like. You have an external schema. People see it from the outside. You have your logical tables that the designers now can see, the people like us creating it, and then the internal, how that relational database management system, how that actually writes the information to the hard drive. And then this is a good perspective from Wikipedia, diagramming that out. And we'll look at more specifics to that diagram as we move. Alright, structured top-down design. This is often called the system development life cycle. And let's run through these main ones here. Analysis. Analysis allows us to gather lots of information dealing with the system. Do we know what they want out? Okay. It's pretty hard to write a database or any system if you don't know what you want out. And then from that you can figure out what you'll need to put in, input, what you want out. And then we have this whole area in the middle here of how we're going to move that to here. What's it going to look like and so forth. And so in there then we start to design. We start to design the system. We start looking at components, modules, interfaces. They talk about all these things in system design. The same thing's true in database. You have to know what you want first, and then you can begin designing the database. Designing entities first, start breaking down the relationships between the entities. Okay, does that make sense? So you start here with an entities. So you have some entity, and then you can talk about another entity. What type of relationship is there between the entities? You can start designing the information. So you're coming from this conceptual view to a more logical view, or the conceptual to a logical view. Okay, so you start designing it, and during all of these steps, you get feedback from the client that you're working for. Okay. Is this really what you want? Is this really what you want? Then we get feedback here. Does this design look like it's going to work? Does this design look like it's going to work? Okay? When you develop, you actually start building it. Okay? So you can take these entities, you're now going to apply attributes to them, start looking at tables and tying those things together. And maybe even get some test data in there and see if it works. Lots of examples and see if so you're actually developing it. Implementation. This is really a good explanation of implementation. First of all, acceptance, installation, and deployment. Okay. You've got the database. Okay, if we're referring to databases, you have the database, and it's all been tested, test data and so forth, and you're ready to put in the real data and put it to work. So you accept the testing, you install everything, make sure it's installed everything you need, and then you deploy it. The huge part of the install is making sure the data you need to add is in there correctly. Then, I'm going to use a different color here so you can see it. Maintenance, making sure it works. And then it's really important to do an evaluation. Is the database giving you what you need? and they give a good explanation here. And then disposal. If you have a database you need to get rid of, what do? Do you give away the hard drives to the local school so they can take all the data off of it? That's supposed to be a joke. Discarding the information system, the hardware, the software, and the transition to the new system. So you got to have a plan for that too. In a lot of these situations, you're working with a client, and when I talk about that feedback loop, that's what we're talking about. You're making sure the client is getting what they need. Okay, it's really important, and sometimes it's not done as well as it should be. And then, of course, you should realize you need to document your work. Not only, it should be easy to read type of information. If a new member comes into the team, they can get caught up. Your clients should be able to follow the documentation. 4 more slides here, talking about organization of data. We develop entities. The entities have characteristics. The characteristics must match the entity. Okay, so the characteristic must match the entity. You wouldn't put a characteristic for an entity and not have it directly be tied to the entity. This will help us in normal form down the road. Okay, those characteristics, more formally, we call them attributes. So the definition I put here is really for an attribute. I didn't like the definition I had here, so I covered it up and I changed it in the outline. All this is about is entities can be in a class. For example, if you created a student table, a faculty table, a course table, and then here's the courses students are currently taking, and these are all linked. Okay, so these are all linked somehow, and maybe like that. This would be a class of entities because they all refer to, let's say, a school scenario. For us, at our level, what we're doing, that's good enough. You can get into classes and object-oriented, and we're not going to do that, at least at this point. All right. And then the last thing about attributes. We can limit what an attribute can be. So it can have constraints. Okay? At the column and data level. The attributes have a type. Okay? Is it a number? Is it a date? Is it just text? And then you can really be specific on all those. You can say what kind of number, date and time, or just date. Is it 5 characters, 50 characters, or whatever. Description. Okay, what I listed here was a data definition language or data description language. Is a syntax similar to the computer programming language for defining data structures, especially database schemas. Okay? One subset of that is, or sometimes referred to as the same thing, is the data dictionary. Okay? But we'll kind of divide, that's part of this entire data definition. Okay? Your attributes can be a single value. You can have just one single value. It can be multi-value. Okay? They can have multiple attribute. Multi-valued attribute can have more than one value. And we talked about examples. Okay? Like someplace they'll list just the name, or they'll list just the name, or let's do a better example of that. I used one the other day, an address. I don't think we used that one yet. If you list an address, you'd have the number and the street, and maybe even the city. Okay, or cities are sometimes listed the city and the state, or city, state, and zip. Okay, even your birth date. It has month, day, year. It really is multiple values. Whereas the name, first name, if it was just a first name, that'd be a single value. All right. Composite attribute, 2 or more other attributes. Consider an attribute such as name that comprises. So a composite would be 2 or more attributes. We talk more about that later on. And the key attributes and constraints. Let's take a look at this. A key constraint. There we're talking about the constraints on foreign keys and primary keys. We can enforce data integrity, and we talk more about that here later on, in which you can take a table, and a table that has a foreign key in it, so we have a primary key becomes a foreign key. You can, within the database, match that up to here, okay? And then force data integrity so that if a record over here, like the record here, was deleted, then the reference to it here would be deleted automatically. More about that later on. This is interesting. There's some controversy over the null, and what I did here is I gave you another example here. You should probably read through that and just see what it says there in terms of the null. Okay. Special marker in this. In a lot of places they'll say a null means there isn't a value. Not available means you don't have the value. Okay? It's kind of like missing, unknown. Okay? You know there should be a value for it, but you just can't get it, or you don't know what the value is. Whereas null, most people say if it's null, means it won't have a value. Okay? It just won't have a value. And there's lots of examples in databases that we'll refer to later on. So as we design it, by the way, anytime the reference he created relational databases, COD. So anytime you have definitions and so forth that relate back to him, they're usually the most accurate. All right. So that ends that section. Our next section, we're going to talk more specifically about relations and relation types and cardinality restrictions, and we'll get into some of this key, primary, and so forth. Foreign and primary keys. That's it.